So good day, everyone. I am Dr. Addison, and today my team and I at Women in Data Science, Trinidad and Tobago, our WiDS team, is going to present to you the data science overview and a short hands-on technical session about the WiDS Datathon 2023 challenge. We are very pleased today to have our guest speaker, Ms. Usha Rengaraju, and I am your host, the WiDS Trinidad and Tobago Ambassador. So before we actually jump into the segments that we have prepared for you today, we just want to give you a little bit of an overview for some of you who are here for the first time about the WiDS itself and what the organization does. Women in Data Science, or WiDS for short, started as a one-day conference in Stanford in 2015. And since then, it has grown globally. So the aim here is really to elevate women in data science, to celebrate, inspire, educate, and support through extensive programming worldwide and regionally. And in that regard, we have a lot of conferences, we have the Datathon, podcasts, WiDS Next Generation, which provide educational outreach for secondary school students. And we also have our different storytelling sessions every month. So what brings us here today really is the climate challenge. And this challenge really involves a data set, which is hosted on Kaggle, and it runs from January 4th to March, actually March the 1st. And in this case, we actually adapting to climate change by improving extreme weather forecasts. So the WiDS Datathon 2023 hosts a lot of global workshops and events. And really the aim is to bring together the Datathon to different communities and to really have everyone support each other, particularly women and underrepresented groups. So really and truly, you can find all the guidelines on the website. I'm just going to give you a few, some of the little points that may intrigue you and may encourage you to join us, which would be some of the team building aspects. 1 to 4 persons. The stipulation is that we must have at least half females on the team. And in that regard, you'll actually build a lot of data science skills through the resources provided. You have access to mentors and workshops, not only from the Trinidad and Tobago chapter, but also globally as well. And of course, cash prizes, which are also available. And you can check Kaggle where it's hosted to see what those cash prizes are. And of course, networking with others for a great cause and for social impact. So in terms of our team, we actually host independent events, which encourage the participation in this global challenge. And of course, you can visit our website at widstt.org for more information on some of these Datathon workshops and of course, some of the regional events. And for those of you who actually just want to dive right into the challenge, I know some of you have already registered, some of you are already participating and working in your teams. Feel free to view the actual Kaggle webpage for the Datathon challenge. Of course, you must register officially, so you have to visit the conference page. Those links will be provided to you in the chat as well. And if you would like to find any events, of course, in terms of our group, you can feel free to visit our website. We also take on team members and mentors as well, and you can email us. So I'm just going to stop here. I'm going to ask persons who, let's see if anyone let's see if you all filled out our Mentimeter poll. I'm just going to share my screen. And I guess this is what we have so far. So the majority of persons are from Trinidad. So, you know, in terms of the word cloud, you can actually see it here. Is everyone seeing my screen?
No.
No? Sorry, let me just share my screen again. Right, so here's my screen. All right, so this is what we are seeing so far. But the frequency, meaning the majority of persons who have joined are actually from Trinidad. I'm seeing some people from USA, from Nicaragua, etc. I know, of course, our guest speaker is residing in Australia, but she's originally from India. So thank you to you all who filled out the word cloud. And let me continue with the session so we can actually get to know our speakers. So Right. So our workshop today consists of two parts. We're going to have an actual non-technical talk, I would call it, which is really just an overview of data science, a beginner's guide, which is a really nice uh, conversation about what data science is, what it entails, and some of the aspects in terms of applications and careers, etc. The data science life cycle and things that you would actually be using when you are in this competition. And in that regard, we also have our guest speaker who will talk about the data challenge itself in an interactive hands-on tutorial. So I'm going to give you a little bit of a background about myself. My name is Letetia. As I said before, I am the WiDS Trinidad and Tobago Ambassador. I'm also a project officer and statistical consultant at the University of the West Indies, St. Augustine campus in Trinidad and Tobago. And I have been involved, I would say, statistics has been my passion for many years in terms of my graduate degrees in statistics and mathematics. In my job, I actually work a lot with student data, and we build data-driven models based on that institutional data. For instance, we do student retention models, which is basically a classification model where you can analyze who may be at risk for dropout. So that has been very exciting in my career to do. And I also in the academic space as well, I have been lecturing statistics, probability, mathematics, and statistical software courses for quite a number of years. So I'm very passionate about the way we use data science in terms of the statistical aspect, building from the theories of the actual models themselves and seeing them actually give us really great insights for more sustainable models to kind of really help our world. And in my case, that's in academia and education. I am very, very honored, though, to really introduce our featured speaker today. She is Miss Usha Rengaraju. Her team won the WiDS Datathon 2022, and she's a head data scientist at Exploratory. I know she's also a Kaggle Grandmaster. So let me just let Usha give you all a quick introduction. Usha, are you hearing us? Are you there? And I know everyone's excited to hear a little bit of introduction to you and your background.
Yeah. I predominantly had worked in investment banking, and a lot of use cases before Exa Protocol was from fintech. And so I've been active in Kaggle for a long time right now. I'm a triple Kaggle Grandmaster there. And with I've been mentoring and teaching almost in every year in several countries across the globe. And I'm all excited about this WiDS Datathon workshop. And thanks to Letetia for organizing this. And you can check out my LinkedIn profile. I'm very active in other communities as well, especially women in data science communities. I recently, I think day before yesterday, I won the TensorFlow Spotlight Award. So I do, I'm quite active in contributing to TensorFlow and other communities as well. You can check out my LinkedIn and Twitter profile. And yeah, I'll be open for questions, post the session for general questions as well. So with this, I'll give it back to Letetia.
Okay, thank you so much, Usha, for that. And as she said, if you all want to find more information on Usha, we'll drop the link in the chat. In terms of her LinkedIn page, you can actually go to our website and you'll find the link for her LinkedIn, as well as all our upcoming speakers for the next few weeks. We have a really nice agenda in terms of every week or every weekend, we have a talk from some of our amazing female speakers locally and internationally. So without further ado, I'm just going to start off the actual conversation today in terms of what we are talking about and why we are all here. And this is just a short overview of data science. So what is data science in terms of the beginner's guide and what we're going to look into here? So we have the actual definition, we have the origins, we have the life cycle, and we have some applications. So where do we start? I know this may be maybe controversial for some, but data science really began in statistics. And it's part of the evolution. The part of the evolution of data science was really the inclusion of the aspects of machine learning, artificial intelligence, and Internet of Things. And of course, with that, we have the flood of new information coming in as we have businesses seeking new ways to increase profit and make better decisions, which is what data science allows us to do, to expand into fields such as medicine, engineering, and more. And this is actually what a definition of what IBM says data science is, which is that it combines math and statistics, specialized programming, advanced analytics, AI, and machine learning with specific subject matter expertise to uncover actionable insights in an organization. Really is to provide that guide to decision making and strategic planning. And just to remind us where this data science is in terms of those different aspects like AI and machine learning. So data science is the whole umbrella, which contains both AI and machine learning. So it leverages on both the AI and machine learning research, industry experience, and statistics. And of course, machine learning involves the algorithms that help to improve these types of decision making through supervised, unsupervised, and reinforcement learning. So of course, we probably never really thought about what the history of data science is because it's such a fusion of all different fields. But if you want to think about it back to 1962, John Tukey expounded on a move in the world in terms of statistics. So he really spoke of hypothesis testing and things that really got us to use statistics to make decisions. And along the way, we can see we moved up the ladder over the years to where we got to talking about exploratory data analysis. And then most recently in the 2000s, we could see that there was a committee for data science and technology. And in terms of data science, we actually had journals. And by 2011 to 2012, data scientists expanded 15,000% in that year. So it's really just to show you the way the world actually took on the aspect or the idea of what a data scientist is over the years and how it really was shaped. So in that aspect, you may be asking yourselves, well, what are the skills needed? So of course, there are a number of skills that are needed for different areas. We know that there are different jobs that are data science related as well. A lot of the times people don't realize that it's not only about the data itself, but it's actually a lot about the domain knowledge and the problem you're trying to solve. So in that regard, you really have to understand what are the context of the problem. In this case, with the climate challenge, we're actually talking a lot about weather and aspects and variables related to that. So we have to really focus on how those things come about, how those variables are shaped in terms of what they mean, and really understand the problem, how it relates to climate when we actually have to dive into the challenge. And not only the challenge, but in the real world, this is what we really have to do. So that is the domain knowledge aspect. And of course, then you have all the technical aspects in terms of the machine learning, the statistics and mathematics aptitude to design and tune and fit these models. And of course, be able to use programming languages as well. So it's a bit of a fusion between statistics and computer science in that way to be able to pre-process the data and validate the data as well. So in that regard, we will want to look at the data science life cycle, which is really what you're going to use a lot in the competition. Certain aspects you will be really focusing and honing in on to improve your skills. So these basic components start off, as we mentioned, with identifying the problems. Then we go to the data collection aspect. You would have already had that in the challenge because we already know the data that we're working with. We would go to data processing and of course, exploratory analysis. And then the data analysis, data modeling, and of course the data deployment. Those are the steps that are really essential. And when Usha speaks about her the technical aspects, she is going to actually walk you through how that looks in terms of the actual coding aspects and being able to understand the insights. And of course, these are the phases in terms of definition, as I just explained. This is what you will walk through as you go from start to finish with your data sets. And of course, in real life as well, some of you work in the field. Even if you're not exactly a data scientist by definition, you probably do interact with data in a number of ways in business aspects. And this is what you would find yourselves doing. So some of the famous data science tools I know in this particular challenge, Python is really the tool of choice. However, it's not limited to Python. You also have things like R, which I am really a big fan of because I use R quite a bit. MATLAB is also a great tool as well. And some of you may also use software such as SAS. Some persons use TensorFlow and all these different things, Tableau, etc. So we really rely on these tools to actually help us to conduct that exploratory analysis. And in a lot of cases, statistical regression if we are building a regression type of model. And most of these tools would be open source. So they support that pre-built statistical modeling, the machine learning, and of course the graphics capabilities. So machine learning at a glance, and this is really the context of where we're heading in terms of the challenge. So really and truly, we want to be able to, as the famous computer scientist Arthur Samuel said, have the ability to learn without being explicitly programmed in terms of the actual computer's ability. So it's actually learning from the data. And of course, we actually use that knowledge that we get from that to make our predictions and conclusions. So it's constantly enhancing and performing the performance and making predictions. A quick snapshot in terms of the different types of learning. In this competition, you would generally be using a lot of supervised learning, which is that it's very useful if you have that labeled data set and you have an idea of what the output can look like. In a lot of contexts, the supervised learning in terms of these types of regression models, as you could see, some of the examples include forecasting in markets, stock markets, weather forecasting, which is really what we're trying to achieve here. And then you also have classification type models as well, like customer retention, image classification, etc. Other types of machine learning would involve things like unsupervised learning, where you have unlabeled data and you want to find patterns and make predictions. So you'd have things like clustering and dimensionality reduction. So you have recommender systems, etc. In terms of that context. And then reinforcement learning is all about real-time decisions and learning the behavior in an environment to actually perform actions without the labeled data. So you have all these different facets or themes when it comes to machine learning. And this is the machine learning life cycle. So we would find ourselves going from where we would have spoken about the domain knowledge, which would really be under one, the project objectives. Then you go to acquiring and exploring data, which you already have in this case. So you would really be leveraging between 2 and 3 and then 4 to kind of go from that exploratory analysis, looking at the features, selecting the variables, building the models, and then validating those models. And in the end, you would actually select the models based on certain metrics. When you do go on Kaggle, you would actually see the metrics that the WiDS Datathon is looking at in terms of the specific scorings that would help you to compete with each other to improve your models on the leaderboard. Right? And this is how that life cycle would look as to where we are heading from EDA up to deployment. Right? So these are the steps Usha will walk you through in the technical aspects, which will be going from distinguishing the attributes, some univariate analysis, looking at the features, seeing if there are any missing values, detecting outliers, feature engineering, and then collecting those insights. And then, of course, the part that's really important is really the testing, the training, the validation, and then those evaluation of those ML models. So we really would have our train sets, our test sets. In some cases, you would have your validation set to confirm those results. And really and truly, we want to go from training it, so looking at those exact patterns from the data, and then evaluating it using the patterns to predict the results. And this is the bigger picture here in terms of from start to finish, in terms of a more going more towards the technical terms, in terms of the hyperparameter tuning, the model testing, the validation, sorry, and then of course that deployment. So at this point, I'm just going to give you some context in terms of the applications. In terms of, I mean, some very simple applications I think we would know is things like when you're on Netflix and you watching specific movies or shows and they give you like recommendations. Those types of recommendations are like from recommender systems. Even when you buy things on different websites like Amazon, etc., you actually see that it's kind of learning your behaviors and what you products you purchase. So all of these things tend to fall under those applications, even online fraud detection as well, and image recognition. Right? And for those of you who have careers or would like careers in data science and want to know in terms of what exactly would it look like, it's not always term data science. People would call me a statistician because of my history in statistics. Some people would say I'm a data analyst as well. So it falls under different places. In terms of machine learning engineers, they would do more of the hardcore work in terms of the actual data itself and the algorithms, etc. And then you have more business type things like market research analysts, data officers, etc. So it's a really exciting field, and it's not just limited to just one term called the data scientist. You can actually have other, similar jobs which are related. So right now I'm going to just give you all a bit of a context before Usha comes in. For those of you who would see the link in the chat on the Kaggle website where the Datathon is lodged, just to remind you, this is where you would begin. And in terms of the overview, you would have the background on the challenge here. The description of the data is on this page. All the sponsors and all the tutorials and resources you can actually see are listed on the side here, the timeline as well, the prizes, etc. I would highly recommend that you go through some of these tutorials. For those of you who are in the competition, some of you would have already been going through these tutorials. And of course, please always remember what is the context of the variables in terms of the actual climate challenge. So it's important for you to actually read and understand some of these resources so you can have a better picture of what the variables do. And I would also show you, well, of course, for those of you who already got into the data, you'd have seen the overview of the data, what you are trying to predict in terms of the temperature, the minimum, the arithmetic mean of the temperature over the next 14 days. And then you also have access to the actual data dictionary in terms of what those variables mean. And you can actually go through all of them and see the links related to the data sets and understand what those variables are. So there are a good few variables. The data set is quite large as well. And if you just want to view the data set as well, you can come down here and actually look at the different variables here. You can download the full data set as well. And you can see a sample of the solution that you have to upload for the competition. So I know you all are very eager and anxious to figure out how do I make predictions and submit these predictions, and what do I need to do in the back end to actually get my model to be tested and trained and actually upload and see myself on the leaderboard, which is currently very highly populated with persons who are trying to improve their scores. So I am now going to actually hand you over now to our feature speaker, Usha. So Usha is going to give us a rundown of a notebook, and she will tell you what that entails now. So Usha, I'm going to stop sharing, and you can go ahead and share your screen and take the floor. Just to let you all know, we'll be taking questions after, but you can feel free to post your questions in the chat if you have any questions as we go along. Either of us would actually be able to answer, right? So Usha, take the floor.
Yeah. So thank you so much, Letetia, for the wonderful introductory session. And that sets the right context for what's coming up next. And so if you do not have a Kaggle account, but you are interested in participating in the Datathon, it takes only 30 seconds to create a Kaggle account. Go to kaggle.com and you can register with Google. If you have a Gmail account, it will just take you 30 seconds to create a Kaggle account. So if you do not have a Gmail account, it also has an option to, use other email IDs as well. But if you have Gmail account, it just takes 30 seconds. So get your Kaggle account up and running if you do not already have one. And for the session today, I've just quickly put across all the links in a Word document just now. And maybe, because I'll be sharing some other materials as well. So, instead of sharing a lot of links in the chat window, I thought I'll put everything up in a single notebook. So, single Word doc. So this will be a reference doc. And if I want to randomly take some notebook and share it, then I might put that link in this doc. So the link to the doc is in the chat window, which you can see. So if during the session, if I want to refer to some notebook, then I'll be pasting the link here dynamically. So it will be one place stop for all the links which I'm going to share. So with this, if you do not have a Kaggle account, get it up and running with just 30 seconds. If you already have a Gmail account, you can just go register using Gmail and your account will get created in 30 seconds. And if you already have one, then it's great. So here I would have given you the link to the competition as well. So click on the competition thing. So Kaggle has got many sections. A brief introduction about Kaggle. If you've got data sets, you've code, you've got discussions, you've got learn as well. So if you're somebody who was very much interested in participating in the Datathon, but you feel you're not, do not have sufficient knowledge in programming, or you do not have sufficient knowledge in machine learning or things like that, then you've got Kaggle Learn, where there's a micro courses. These are called micro courses because it just takes 4 hours to complete. These are small, tiny micro courses for you to get started. You have a separate micro course on time series as well. So you can look up to it. And these are courses which you can complete in, if you just have put in some 10 to 12 hours of effort or max of 15 hours, you can complete all of these micro courses. And if you are an absolute beginner to machine learning, then these micro courses, because this is a very diverse population we are dealing with. So just in case if you fall under that category where you're absolutely new to machine learning, but you're very passionate about this hackathon, you want to solve for climate change and things like that, but if you do not have the sufficient skills, then go to Kaggle Learn. You've got all these micro courses. These are called micro courses because each of these courses will just take you less than a hour to complete, and that way you'll be done with all of it in less than 15 hours. And you have separate courses for time series and all of it, which might be very much useful for this particular hackathon. And Kaggle also has got discussions. So if you go to this particular competition specifically, WiDS Datathon, if you have any queries with regards to the data set, then you can always create a discussion post. To create a discussion post, all you have to do is create a new topic. Whatever query you have with regards to the rules of the competition, or if you have queries with regards to the data set, or if you have an insight which you want to share with the rest of the WiDS participant, then you can create a discussion post. Or you want to share any other data science information which you think the participants of this competition might find it useful, share it, but do not spam this category. Spammers, don't spam it. Just share only the useful and relevant information. And there are a lot of people who have shared their discussion post. If you feel you can answer those questions, you can also go and answer those questions. This is a great place to network, find friends, and if you have not found a teammate already, this is a great place to network and find teams as well. Outside this, you also have a code sections where a lot of people have shared their notebooks, which you can use it as a reference. So you don't have to start anything from the scratch. Even I have put a notebook out there. So you can use these reference notebooks to get up and running. So you have something to start with. You're not like solving something which doesn't have any reference materials. You have a lot of tutorials under the resources sections as well for you to go through. So there's a lot of materials to help you get started with. And outside this, which there are a few things which I would like to point out. See, if you're going to be, because a lot of people who are new to Kaggle are participating in it. So you'll have to keep in mind something called private sharing is not allowed in Kaggle. So if you're going to come from the same country and the other, you are part of two different teams and you're friends, but you cannot share tips and techniques of the competition to your friend. But if your friend is in a different team, then you cannot share it. That's called private sharing. Private sharing is not allowed in Kaggle. It's against the ethics of the competition. So if you're new to Kaggle, you may not be aware of these rules. And a lot of people do private sharing. and they get caught. Kaggle has got a system which detects all these private sharings, and because of this, you will not get caught during the competition. The elimination happens after the competition ends, which means you would have put in 2 months of hard work and effort, and then finally at the day of the competition, your name gets disappeared from the leaderboard. And there were a lot of people who were not aware of these rules and had committed this mistake unknowingly, and they put in like 2 hours of hard work for hard work, 2 months of hard work, and all of it had gone waste. So just in case, if you're a novice and you're not aware of this rule, please keep in mind, you may be friends, but if you're in different teams, you cannot share tips and tricks, and you cannot share codes and all of it. You can share information only within your teams. The second rule, which I found a lot of, because I've been a mentor and I've been an instructor for WiDS Datathon for the last few years. So these are common mistakes which a lot of people do. And at the end of, I think there was one team which was in the 6th rank in 2020 Datathon, and they got eliminated because they did private sharing. And so they were wondering why they were not in the leaderboard after the competition ended. So people felt really bad because they were like spending all their weekends on the competition and putting in a lot of effort. Second thing which you need to be very careful is you cannot have multiple accounts in Kaggle. If you have 2-3 accounts in Kaggle, again you will get eliminated. You will not get eliminated during the competition. You will get eliminated on the day when the results come out, on the day when the competition ends, which is again a lot of hard work of yours going waste if you have multiple accounts. Please do not have multiple accounts in Kaggle. People unknowingly have multiple accounts in Kaggle and they get eliminated. So that is again a very bad thing. Please avoid these things. So these are some, things which you need to be aware of if you're not very familiar with Kaggle and the way Kaggle works. A lot of people might think, you can fool around the system and things like that, but Kaggle has been there for 11 years now. So they pretty much know most of the tricks and tips of how people, cheat the system and things, and they are prepared with it. So try not to engage in those activities. Just be honest and just keep learning as your focus. And yeah, this is just a bit of an advice which I want to start with. And now let's get started with the competition. So this competition comes under AI for climate change, and WiDS team has always been passionate in choosing problem statements, which is very much useful for the community, or AI for social good. And this particular competition is forecasting temperatures. So for a 2 year, you have a lot of details, climate and weather related information for a period of 2 weeks. So for every start date with 2 weeks, in the 2 week span time, you have all the weather related and temperature related information, and your job is to forecast the mean temperature in that 2 year window, 2 week window. So you'll find the maximum and the mean of maximum and minimum temperature in that 2 week window. And that is the target variable which you need to forecast. So this is what is the problem statement. You have a lot of the evaluation. This is a regression problem. So the evaluation metric is root mean squared error. So under evaluation, you've got the root mean squared error. And when you click on the data tab, I think she has already gone through it. You have the trained data CSV file, which you need to use for building your models. And for predictions, you'll use the test data.csv. Test data.csv does not come with target variable. So this is the one which you will use for predictions. And you also have something called submission, just in case you're not familiar with how Kaggle work. Kaggle competitions always come with sample solution.csv or submissions.csv. These are files which always contains the format in which you need to submit to Kaggle. So this here this is the target variable, context underscore temp 2m underscore 14d temp 2m. This is your target variable. This is the arithmetic mean of the maximum minimum temperature in a 2 week window. And so this is a format in which you need to make the submission. So this is a CSV file. So with this being said, if the data set is huge, Kaggle gives you, Kaggle gives you 40 hours of GPU every week per person and 20 hours of TPU per week per person. So if you form teams of 4, you will be having good sufficient amount of GPU if you have teams of 4, and with minimum of 2 women participants, and you'll get like around 160 hours of GPU, and you'll have 80 hours of TPU, which is good enough for a week. And yeah, this is about the general instructions about Kaggle. Once you complete your solution, once you complete your end-to-end coding, you've completed all the end-to-end, solve the problem and all that. When you finish that, you will, any notebook you click here, you go to the data tab, you will have this submissions.csv file. So anything which is open sourced in Kaggle, which is made in public in Kaggle, is something which you can consume. As long as it's open and access to everyone, you can consume it. So now these are public notebooks which are open and accessible for everyone in the world. So you can make use of filters, filter by most votes, filter by not most votes, filter by best score. So if you filter by best score, this is a particular notebook which is having the highest score currently. So I'll go to this particular thing. Highest scoring notebook, highest scoring public notebook right now. But you can always filter it out of the current highest scoring public notebook. So this is going to be our highest scoring public notebook. So click on this. So when you click on this highest scoring public notebook, you just click on the data tab. When you click on the data tab, you will have something called submissions.output. Under output, you will have submissions.csv file. Just download this submissions.csv file. Go to the highest scoring notebook, click on the data tab. Under output, you will have a submissions.csv file. Please download that submissions.csv file. Once you do that, you can click on the competition page and you will have a submissions tab. And in this submissions tab, you have an option to submit your predictions. Click on browse file. The CSV file which you have downloaded to desktop, uploaded. So it's uploading. Once you've uploaded it, click on submit. This is how you make submissions to Kaggle. You don't have to submit your entire notebook. All you have to submit is just the CSV file. So this is the current high scoring notebook. I put it in the Word document, the high scoring notebook at the moment, high scoring public notebook at the moment. Please click on that notebook and you will have the data tab. Under the data tab, you have the output. Under output, you have submissions.csv file. You can download the submissions.csv file. So high scoring notebook data tab. Under output, you have submissions.csv file. Download it. Once you download the CSV file, the next thing what you'll do is go to the competition page. Under competition page, you'll have an option called submissions, under which click on submit predictions and upload your CSV file and click on submit. So this is how you will make submissions to Kaggle. So on a given day, you will be able to select, on the final day, you'll be able to select only 2 submissions. So you'll be making a lot of submissions like this. You can select only 2 up for final evaluation. If you do not select anything, it will automatically pick the highest scoring submissions in your public leaderboard. So this is how you make submissions to your competitions in Kaggle. So now we have covered how to make submissions to Kaggle, how to make the best use of Kaggle platforms in general, and what are the do's and don'ts in Kaggle platform. These are some of the things which we covered. Now coming back to the competition, we have seen what the target variable is. It's about the target variable is forecasting the mean and the mean of max and min temperature in a 2-week window. So this is what you need to forecast. And you've got what is the input which you have got is you've got temperature, precipitation, sea surface temperature, and multi elevation, pressure. These are some of the climate and temperature related variables which are given as input to you. And you need to predict the mean temperature in a 2-week window. So this is what is the problem statement. For this problem statement, let's get started with, for people who are not very familiar with Python programming language and who are not very comfortable with coding, the best option is to get started with AutoML tools. Under EDA, the first notebook I would have put is in Auto EDA. So if you just go to the Word doc, there is something called EDA Notebooks. The first notebook which I would have done is Auto EDA. So this particular notebook uses a couple of libraries which are AutoML tools for data analysis and data visualization. If you're not very much comfortable with programming and you just do not have sufficient time to pick up programming in the short time, then you can just go to AutoML tools. Even there are AutoML tools for everything. There are AutoML tools for visualization, modeling, feature engineering, hyperparameter tuning. So every process in the ML pipeline can be automated. So you can pick up some AutoML tools which are very easy to use and doesn't require much of a programming skills. The first tool which I'm going to show you is about WiDS. WiDS is a great tool for visualization. So to use WiDS, you just have to install pip install WiDS, and then you can you'll be importing WiDS library, and then WiDS.analyst, you pass your data frame which you want to analyze. Here I'm passing the train data frame, and it will give you a report which you can store it and later print it out. So it is as easy as this. So if you're not very familiar with programming, what you're trying to do is you're trying to install the software and then call the library analyze method and pass the data frame for which you want to create a report. And you can also use other libraries like Pandas profiling, which is a similar library, which is very easy to use. Again, pip install, import the library, and post data frame for which you want to do an analysis and create a report. So this is going to be very, very easy, and this gives you a quick dashboard of all visualization, of all distributions of all input variables, anomalies, missing values, all of the statistics you can get with just 3 lines of code. And that 3 lines of code also is available in documentation for you to use. So there is a couple of libraries which are covered here, but there are a lot more AutoML libraries for visualization. If you're not comfortable with programming, I think this might be a great place to get started with. So then let's get started with another analysis notebook here. So my notebook predominantly involves deep learning for tabular data. So before we get into deep learning, we'll cover a couple of traditional tree-based models. So this is again a notebook which deals with tree-based models. So in this notebook, any notebook which you want to run along, you can just click on copy and edit and you can run along. You can run along, click on copy and edit, and you can just click on run all, and you can run all the cells at a single shot. Or you can just view the output without running as well. So in this particular notebook, we are importing all the libraries. We are having a train data set, test data set, creating data frames using pandas. And we can, there is basic exploratory data analysis, like what are the variables out there. So these are the variables. You can use head method to inspect the first few rows. And you can also see the target value. This is your target value for which you need to forecast. And you can see the other information about the training data set. So you have got 3,75,000. So these many number of rows, and you've got 246 columns. And The other information is you will be more interested in finding if there are any missing values in the data set. So there are some variables which has got missing values, and how to handle these missing values. There are a lot of techniques for handling missing values. You can use either KNN imputer, which are machine learning based imputing techniques, or you can also use the traditional imputing techniques like mean imputations and things like that. So there are some variables which have got missing values. In this notebook, the author uses mean imputation. And just after doing imputation, and then, if you check, the test data set doesn't have any null values. It's only the training data set which has got the null values. And there is one more date variable, which is the start date available. And from the start date, you can actually find out a lot of features. So from the start date, you can actually find year, month, day, and all these variables you can extract from the start date. And for handling null values, if you just want to create a baseline, then you can try with missing value imputations, techniques, and things like that. And then after your missing value imputation techniques, there are no null values. You've imputed all the values with the mean values. Then there are once you have extracted some useful features from the start date. So from a given date, you can extract what is a year, what is a month, what is a date. After extracting these useful information, you can drop off the start date. You can also drop other variables like index and all that. And if there are any categorical variables, then you should encode these categorical variables into numerical variables. You can try label encoding techniques for it. Again, you have scikit-learn packages where you have label encoding, which you can use to convert these categorical variables into numerical variables. And so climate region here is a categorical variable. So you need to convert this into a numerical variable. Before, a visualization is a great step for you to analyze and get to know more about the data. So there are plenty of EDA notebooks available out there, which will give you a good insights about various visualization things. And the authors have exhaustively tried all possible visualizations for you. And I would highly recommend go through the existing notebooks in the public forum. So this notebook also has got some visualizations of few of the win variables. You can just see the visualization and the feature distributions of these variables to find out if there are going to be any anomalies in the distribution, or if it has got what kind of distribution each and every variable has. So these are exploratory data analysis, which you can try for all 246 variables. And you can chunk the variables, 246 variables, into multiple chunks, and you can start analyzing chunk by chunk. Maybe you can first start analyzing all the wind related variables, all the precipitation related variables. And you can also see the target just check out before doing any program modeling, starting your modeling, find out the distribution of the target variable as well. So here it's a regression problem, so it's not a problem. But if you're dealing with a classification problem, you'll have to ensure if it's an imbalanced data set or not. So since it's a regression, so I don't think there's a problem with that. So once you've done the feature engineering and analysis, the first thing you can, since this is a tabular data problem, tree-based models have always been got a history of getting very good performance in Kaggle competitions particularly. So the famous tree-based models are CatBoost, XGBoost, and LightGBM. So you can try these tree-based models first before you dive into deep learning. So here in this notebook, a couple of tree-based models like XGBoost and CatBoost had shown how to use XGBoost and CatBoost. So you can just import the XGBoost algorithm API library. And then once you import it, you can just use scikit-learn to divide your data set into train test split, and then call the XGB regressor. XGBoost also has got classifier and regressor. This is a regression problem, so you're calling the XGBoost regressor, and then give values for your parameters of this model, hyperparameters of the model. And these hyperparameters can be tuned with, hyperparameter tuning software like Optuna. And there are multiple other hyperparameter tuning techniques. You can use one of the open source hyperparameter tuning techniques for tuning your hyperparameters. And once you tune these hyperparameters, then fit your model and start making predictions. You can also find out what are the features which has got using a feature importance attribute. Most of these model algorithms, tree-based algorithms, comes with a feature importance attribute. To the model predictions. So you have the context. There are a few more, you can see some of the features which are actually having a higher influence on the model predictions. So it's very easy to use, and there are a lot of notebooks out there which uses XGBoost. And similarly, CatBoost is again going to be a very easy thing. You will have to install CatBoost and then import the CatBoost library. You can use CatBoost regressor, give random values, or get started with some random values for the parameters. Again, fit your model and start making predictions. So this is a sample notebook for using tree-based models like XGBoost, CatBoost. You have some sample notebooks for LightGBM and other tree-based models as well, random forest and things like that. So in today's session, we'll be covering more about how to use deep learning techniques for tabular data. In particular, we'll be using an algorithm called TabNet. TabNet has always been very successful in especially competitions where there's huge volumes of data. So since the data set is huge, you can start dabbling with deep learning for tabular data as well. So for deep learning for tabular data, just click on the workshop notebook here. So this is going to be a notebook. You can click on edit and copy. So once you click on edit and copy of this notebook, if you want to follow along, you can just follow along. Click on edit and copy. So this is any notebook you open, you just want to run it, then you can click on edit and copy. And every time you do an edit and copy, when you open it, it takes some time for the blue signal to come. Only when the blue light comes, it means you are ready to run your programs. Here, the blue light has not come, it is still in gray. So you can click on start. So now the green light has come. The green light means signifies you can start running the notebook. So the first thing you do is you do edit and copy the notebook. Click on edit and copy, and you wait till the green light comes. If it takes a long time, click on the start button and it turns green. So if you do not want to run cell by cell, you can click on run all. This notebook uses weights and biases plugin for dashboard. So you may have to have an account with weights and biases add-ons as secret added to it. So you can go to vanv.com. So you can go to weights and biases website, create an account there. And when you go to your account, you will find your API key, which you need to give it as a secret. If you want to use weights and biases for tracking, experiment tracking, I'm using weights and biases for experiment tracking. There are a lot of other open source tools as well, like Nipun.ai. There are multiple other open source tools. You can use whatever works for you. So you will have to again you can use a Gmail account for creating an account in weights and biases. Once you create an account in weights and biases, you can go and you can create a project here by clicking on new project. And for every project you create, yeah, you can find all the reports here, all the tables are just created, artifacts are just created, sweeps is for hyperparameter tuning. And so you can track all your entire machine learning pipeline using weights and biases. It's an MLOps tool. So the session is not about MLOps today, so I'll not be explaining much in detail, but you can always go home and after the session, you can always explore this. So once you create an account using Gmail, then you can click on settings. Here is where you will find your key. So you'll find your key, your API key, which you can use it for tracking your experiments. So I have used my API key. So if you're going to, don't use run all while you're running this notebook, because the parts where weights and biases, if you do not have an API key, it'll throw up an error. So run the codes, only the cells which does not have weights and biases. So you can run this PyTorch, Tabnet. You are installing the PyTorch Tabnet. Tabnet is a transformer-based architecture for dealing with tabular data. Its transformers has been very famous with NLP, and now it's also been famous used in computer machines. Why not now transformers are predominantly used in tabular data as well. They're quite successful in places where data sets where with huge volumes of data, I think they're good in terms of performance. So this notebook is about using tabular transformer-based tablet architecture for which is a deep learning architecture for tabular data. So skip the cells where weights and biases is there, because if you do not have your own API key, it's going to throw error. So you can so you can install, this part is about importing all the libraries which is required for this particular notebook. And this part is where if you have your own API key, you will have to give it here, or you can go click on add-on secret and you can create your API key and the value for it. So you can skip this part, because at this point you may not have a weights and biases login. But it's always recommended you use some kind of a machine learning experiment tracking tools to track your experiments, because over this period of 2 months, you would be conducting like hundreds of experiments. And if you have teammates, then you will have all 4 of you will be running up to like hundreds and 200s of experiments, and it's very difficult to keep track of what is your best performing model, what's your best performing hyperparameters for that model, because each of you will be trying on your own. So it's always good to be organized by using some form of a machine learning experiment tracking tool. Whatever works for you, and any open source tool which works for you is good. And so this is about weights and biases. Now I'll head on to the other parts of the code. I'm taking my training and test data sets, creating a data frames using Pandas library. This data set is huge. So I just sampled 1,000 rows, because if it's more than 1,000 rows, it's going to take 2-3 hours for running. So, if I have to show quick demo, then I don't want to exhaust my GPU. So that is why I've sampled 1,000 rows. But for your, you'll have to remove this line and you have to train it on the entire data set if you want good performance. Since I don't want to exhaust my GPU, I've just sampled 1,000 rows. But if you're working on the competition, do not do this. Train it on your entire data set. With that being said, here this notebook, I'm exploring the missing values. There are some features which missing values. Again, there are several techniques for handling missing values. You can use KNN imputer and other advanced form of imputers, or you can go with traditional mean-based, median-based imputation as well. There is no hard fast rule that this is the technique which is going to work. It's always, in general, it's going to be experimentation. You can experiment with few techniques and see which is giving you the best performance. So I can get the statistics of all the variables. There are around 246 variables here. So here I'm seeing the distribution of target variable, and I do not see any abnormalities in the distribution. You can also see the distribution of the numerical variables. And there's only one categorical variable, which is climate regions, and you can see. So here I see there are a few of the climate regions which has got higher number of data points compared to the others. There are some regions where there's very, very less data points as well. And Weights and Biases again has got an amazing dashboard where you can log all your plots to. Please do not run this block of code where Weights and Biases is there, because you do not have the key at this point of time. And feature engineering, again, I'm taking the start date and I'm extracting features like date, year, month, and day. And then label encoding, I'll have to convert. There's only one categorical variable which I have to convert into a numerical variable. So I'm using a label encoding technique from just already implemented in scikit-learn to do this job. I'll drop the since I've extracted the meaningful features from start date, I'll drop off start date and index. So missing values, just to save some time, I'm just like dropping off all the missing values here, but you can try out some kind of imputation techniques, which you can try out all the techniques and see which one works out best. And it's always a good practice to drop the highly correlative features. There are several libraries like Yellowbrick, and you can just do in your pandas data frame, you can just call the .core method, CORR method, to find out the correlations between all the feature variables. And if you see any correlations which is above 85 or above 90, then you can drop off the variables with high correlations. You can do that as well. If you just want to visualize the correlations of variables, you can just use Yellowbrick to visualize it. Again, there are 246 variables, so this is kind of congested. If you use the same library for visualizing any data set with 10 or 12 features, you'll be able to get better insights. And the next part, again, you can skip off the weights and biases part. And the next part is going to be about taking the train and test data set and splitting it up. And finally, TabNet. So TabNet has also got an open source implementation in both PyTorch and in TensorFlow. We're using the PyTorch implementation of TabNet. To understand about TabNet, all you need to understand at this point is it's a transformer-based architecture. It's a deep learning technique for dealing with tabular data. And we've got an implementation, so you don't have to run any the implementation of TabNet from the scratch. The PyTorch implementation is already open source. You can just do a pip install and get started with using it. So here the TabNet has got hyperparameters. Any machine learning, deep learning models has got hyperparameters. So you will be employing a hyperparameter tuning technique in your any open source tools which deals with it. So here I'm using Optuna. Outside Optuna, there are a lot more other tools which does this hyperparameter tuning for it. So the way Optina generally works is, even scikit-learn has got grid search, random search, CV, and all that. So you can try any of the techniques which works for you. So the way Optina works is, I put a Medium article to which you can check it out later. So in Optina, you'll always have an objective function, and you will be defining if you want to optimize this, maximize this objective function based on a certain metric, or you want to minimize this objective function is something which you will decide. And once you have your objective functions, and then you will create a steady variable. And then you will mention whether you want to optimize this objective functions or minimize it for how many number of trials, how many number of experiments. So it involves creating objective functions and mentioning whether you want to maximize or minimize a particular metric. And what is the best hyperparameters for the maximum value of a hypermetric? This is what you're going to figure it out. So usage of Optina is very easy, and you can just go to the documentation and sample codes on how to use hyperparameter tuning, seeing how to do hyperparameter tuning using Optina. So here, again, I've written my objective function. So I'm for this particular data set for TabNet regressor, I want to minimize the RMSE value. So this is my objective function. So these are the parameters which I want to optimize. So the best values of these parameters. So you have to mention whether you want to minimize it or maximize it. So I want to minimize it here. And I will be creating a study for the objective function which I've created above. So I'll be minimizing my loss here. So this is how you use Optuna. And once you run this, it'll give you the best params. Attribute will contain all the best values of the hyperparameters after you finish this hyperparameter tuning. So if you just call the study.best params, it will give you the best values for all the hyperparameters. Now for my tablet model, I've got all the best, I've completed hyperparameter tuning and I've got the best values for all the hyperparameters. I can directly plug into my model. So I'm calling tablet regressor. This best type of parameters, I'm storing it in a variable called final params and passing it to my tablet regressor, fitting the model, and then you can make predictions on the model. And then finally a CSV file will get generated, which you can upload it to which you can make a submission to the competition. So this is about how to use Tabnet for the WiDS Datathon, which is using a deep learning technique for the tabular data set. There are a lot of notebooks which are there in traditional machine learning techniques. So I thought I'll create a deep learning technique notebook. So you get a flavor of all kinds of techniques that way. So with this, we have come to the end of the session. So you can try out all possible techniques and then you can try ensembling of models to improve your scores. And so, yeah. With this, we have come to the end of the session. So if you have any questions, we can answer that.
Thank you very much, Usha. That's a very compact set of tools and resources for us to use. I know some of you are more advanced, so some of the aspects of the resources would really be suited to you as well. And of course, I'm very happy to see that you mentioned the AutoML tools for those of us who may not be working with Python all the time and may need some supporting tools to help us along, especially for those of you who really just want to get a feel for how to manipulate the data. I'm not seeing any questions in the chat yet. Does anybody have any questions that they would like to ask Usha? Particularly, I know I have some of my mentors who are competing in the challenge. Do you all have any questions for Usha at this point in time? Please feel free to ask her. She's very, very, very knowledgeable, as we have seen so far. Anyone has any questions?
Yeah, hi. Morning.
Yeah, hi.
So I had a
one of our
question.
mentors. Go ahead.
Yeah, hi. Nice to meet you. I had a question about the approach, right? So you mentioned the use of AutoML tools, and what I wanted to do was take a slightly different approach. And in the description of the WiDS, they mentioned to use physics-based machine learning models. Do you have any recommendations or direction for getting started with physics-informed machine learning as it pertains to this problem here of temperature prediction with the weather variables we have?
Let me check that notebook first before commenting on it. I haven't checked out all the resources because one of my resources there. So the physics-based model is from Arthur, is it? Which one is it? Who is given the physics-based model? Is it Arthur?
They don't really have a physics-based model there, but they made mention of it. I think it's in the description or somehow indirectly mentioning that physics-informed machine learning models would have been a possible approach, and it does seem like a really good idea because it deals with using existing weather models, which will have underlying physics. Finding a way to probably exploit that with machine learning seems like one of the better approaches. And I just wanted some direction as to how to get started with that.
I've not really worked a lot with physics-based models, so I may not be the right person to comment on it, but something which really, I came across recently a couple of days back was a paper called ETS Firma. This is something which I would recommend if you want to explore the other, something outside execution, something outside, outside the other deep learning transformer based models, you want to just try out something, then I would recommend, this was a recent paper which came out in 2022. So this has a flavor of both traditional statistical models like exponential smoothing. So it brings in that statistical flavor, and it also brings in the transformer based model. So the data set is huge here. So deep learning techniques can have a shot if you just choose the right deep learning technique, and but you still want some kind of an information which the traditional statistical models captured as well. So if you want the mix of both worlds, this is a 2022 paper which has come out, which is ETS former, which is exponential smoothing transformers. So this is something which I would recommend if you want to try out some offbeat models. And physics models have not worked on it, so I wouldn't be able to guide you in that direction. But I would definitely recommend, going through the papers which has come out for time series forecasting in 2022. Most of the papers will come up with an accompanying GitHub repository, which means you do not have to implement the paper from the scratch. The paper is already implemented. So you can straight away start testing it out in your data sets. And the GitHub repository also contains instructions on how to use it there. For example, this is a paper which has come out in 2022. It got published in one of the top conferences. So now to find the code of this paper, I'll just do ETS former GitHub. So I've got the notebook already implemented in PyTorch. So they would also contain step-by-step instructions on how to run it on your data set, you'll have to place the data set in a certain folders and then start running the SH files. So this is already implemented in PyTorch. So most of the papers will already come with accompanying GitHub repository. So you can try out all the papers which has come out in 2021 and 2022. You don't have to implement anything from the scratch. The implementation, PyTorch implementation for sure is available. So that way you can check if there is any paper which has come out in the intersection of physics-based modeling and the time series forecasting. And if it has come, then you can check it out. So the place where you can actually go and check it out, there's, instead of having dependency, instead of going and asking somebody, if you want answers to what are the recent papers which has come out and things like that, the way you can do it is using papers with code. So if you go to paperswithcode.com, so you can click on browse state of the art. So this is not just for time series forecasting. For WiDS, it's time series forecasting, but your data science journey doesn't end with WiDS. You after WiDS also you'll be dealing with a lot of problems. So for any problems, go to this web page called Papers with Code. Click on browse the state of the art. So you have a lot of problem statements under which you have all the top performing state of the art models. So here it is going to be time series forecasting is what we are trying searching. So this is time series. So time series and time series forecasting. So I'll click on time series forecasting because we are dealing with a regression problem, right? So you can click on time series forecasting. So I've clicked on time series forecast. Now I have got all the top performing models, the data set. So for a given benchmark data set for all the top performing models, the corresponding research paper and the corresponding code. So most of the papers come with code. So you don't have to write the code from the scratch. You can just follow the instructions on how to prepare your data set, place it in the right folders and run the SH files, and it should work fine. So this NN linear is the top performing model for this particular data set, benchmark data set. So I can click here, open the paper. So I'll be able to read transfers for effective time series forecasting are transformed. This is a paper and the corresponding code is here. So you have a code implementations in Python. So this is not just for time series. For any given problem statement in image classifications or NLP or anything, you can just go find out the top performing models and the recent paper and the corresponding GitHub repository for any problem statements under any multiple domains. So for time series forecasting, it's here. So just in case if you're interested in other things as well. So you can try it for physics-based modeling as well, maybe. So this is physics-based time series. I'm just searching. I'm not sure if you'll get the results. You can just try it. If you get it, then you can just check out. might require a lot of searching and reading few papers to see. There's one something climate change, but you'll have to dig through it. This contains all the recent research papers with their corresponding code. So you can dig through this website to find out if there's any physics-based time series forecasting techniques out there which has come out. But I have not personally worked in physics-based models, so I'm not commenting on it. Yeah. Have I answered your question?
Yes, thank you. I actually
Thank you
use
so
that site
much.
of my class too, so thanks.
Yeah, thank you.
Thank you so much for that, Usha. That was really I am actually very interested, especially with the research papers with code. That link, especially for people who are in research, that is a really great resource to know. Anybody else has any questions for Usha? I could also suggest, based on the WiDS website as well, that you check out climatechange.ai. They are also one of the sponsors, and they may have some resources that may be, as well as in, I am not informed on the physics-based models either, but I could probably direct you to persons who may be better able to answer that question, as Usha also said. I think I'm seeing a hand. Does anybody have their hand raised?
Hi.
Yes.
Yeah.
Great. Go ahead.
Hi. Hi, I'm Samya. Thank you very much, Usha, for this session. This is awesome. I have one question in terms of like after we clean up the data, there is the split and fold technique. How can I learn more? I know in one of the other session, I learned that there's two such techniques. One is 80-20 rule, or the K-means or K-fold method. So if where can I get any more resources where I can learn what are the different such techniques available and which is suitable for what scenario?
Yeah, so I think you can check out the Kaggle Learn course, where you will find it under supervised intermediate machine learning is what I gather. It should be in machine learning. Yeah, under machine learning, this is from Kaggle Learn course. So here you will find that model validation, you will find it here. So how to build your models and things like that. These are notebooks, which are very short notebooks for you. So this is the course which you need to take on understanding translate validation, just in case if you're not comfortable with the course, the way the course is structured. Um, Anything in Kaggle, if you want to learn, you can just use a search bar, K4 cross validation. So this is what I want right now. So I just, for anything, this is your query at this point of time, but in future you will have a lot more queries as well. So the first thing when I was starting out, I used to do is I just, any reference notebook which I want, I'll just go to the search bar, type it. You'll find you've got filter it out based on notebooks after you search things, and you've got stratified group K4 cross validation. There's a tutorial on K4 cross validation itself. And so these are notebooks out there. So just explore like 3 to 4 notebooks. Maybe this comes across as a good notebook. See if it's in Python. You have filters to filter out notebooks only in Python. A lot of people have uploaded it, and a lot of people have forked it as well. So this contains an elaborate discussion on what is graceful validation and things like that. So for cross validation, we got it in the first search, but Kaggle is a great place for you for finding out any tutorials with regards to Kaggle competition, specifically in the context of Kaggle competition. Kaggle is the first place you need to come and check out. Outside Kaggle, if you're not specifically searching in the context of competing in Kaggle, but generally to upskill yourself, I think towards data science, analytics India, magazine, analytics Vidya, these are good resources where they have YouTube channels as well. These are good resources where they've got multiple tutorials out there to guide you with how to get started with data science, and all the basics concepts covered elaborately with theory and the code snippets. So please do check out these websites. And for this K4 cross validation, I've shared it with you. So again, it depends from case to case. There is no general rule that this 80-20 or 60-30 is going to work for you, but it is just an experimentation of different techniques and finding out what works best for your specific data set. So yeah, K4 cross validation, I think might work well for this particular data set, but again, it's a trial and error.
Thank you. That's very helpful.
Yeah.
Great, thank you so much. Does anybody else have any questions for Usha today?
Hi, I have a question.
Yes.
When you, Miss Rengaraju, when you went through your notebook, you said that you use tablet and you also use the PyTorch version. Is there a particular reason why you chose to go with the PyTorch or PyTorch implementation versus the TensorFlow implementation?
No, PyTorch implementation is very easy to use. You can use TensorFlow implementation as well. So the performance wise, I think at some times, very rarely, in certain competitions, TensorFlow might implementation of a certain paper might give a better performance, and PyTorch implementation might give a better performance in certain competition, certain papers. So it depends from use case to use case and paper to paper. So in tablet, I think I just use PyTorch implementation because it was easy to use compared to the TensorFlow. That's all. But TensorFlow, I think implementation, the whole tablet papers comes from Google. So the Google has released both the TensorFlow official repository of Google contains the TensorFlow implementation. And if you want a sample notebook on how to use a TensorFlow implementation, also you'll find tablet. So this is tab transforms. So tablet, TensorFlow, I think you'll have the official repository coming from Google itself. But outside that, in Kaggle also, you have got TensorFlow 2.01 tutorial. And there are unofficial repositories, which is not coming from Google, but other aspirant data science people who are very good, they might have put. But Google itself, since Google released it, if you go to the official Google repository, you'll find the entire source code for tablet and TensorFlow as well. So for me, it's just, I found the tablet version very easier to use. So I just used it, and I rarely use PyTorch in general. I mostly stick to TensorFlow. I thought I'll just give PyTorch a shot, that's all. But there's no such intention for me to choose, PyTorch over TensorFlow in this context. But there were competitions in the past where TensorFlow implementation was better than PyTorch in because Kaggle, this even 0.0001, the accuracy matters a lot. The leaderboard is purely based on your score metric, right? So sometimes in the past competition, we have seen sometimes TensorFlow performing really well for a certain research paper implementation. Sometimes PyTorch performing really well. So it's been very random. It's never the case TensorFlow always performs better or PyTorch always performs. It's very specific to the research paper. There have been competitions in the past where one has performed better than the other, but here it is just I just chose PyTorch without any other agenda or things that I just like that chose it.
All right, thank you.
Thank you so much for that question as well. Does anybody else have any questions for Usha? I'm seeing someone. Thought I saw a raised hand. Anyone else? I would have one last question if no one else has a question. Usha, in terms of like the teams, because you were part of the winning team last year. Do you have any tips for those of us who are participants in the competition moving forward between now and, of course, the submission time, which is March 1st? Any sort of tips or tricks or anything aside from what I know you have given us a wealth of information. So, is there anything else that you would like to let us know?
Yeah, what I would try to tell you is feature engineering, ensembling, and post processing is the key to any winning solution. So, any of the Kaggle competitions you take, the differentiator is going to be three things: how you tune your hyperparameters, that matters a lot, and what are the feature engineering, especially in tabular data. Feature engineering is the number one goal to sell, which is going to decide a will. So coming up with interesting derived features, using the domain knowledge or the existing data itself, using other traditional techniques. So feature engineering, you need to invest a lot of time. Outside the feature engineering, sometimes, post processing techniques helps as well. So coming up with some post processing techniques, which is very, very unique, which you need to come up with. You need to think through and check out the data set, and things like that. There are no standard post processing techniques which will work for all data sets, and these are very, very specific to the use cases, and you will have to decide on what you can do to further improve your scores. Ensembling techniques always helps a lot. Ensembling multiple models in Kaggle, especially, not just with Datathon. In Kaggle, traditionally ensembling has worked really, really well. So these are areas which you need to focus on to climb higher up in the leaderboard. Form teams, because sometimes it might be, very demotivating, or it's very difficult to find interest to work, especially when we all are having a different full-time job. Some people might be studying and things like that. So if you have a team, you can motivate each other up, fix timings and works as well. So definitely four people is always better than one, provided you choose your teammates really wisely. So because even one of you in your team is having a double account, Kaggle team will not agree that only my teammate had two accounts. It's not me. I did not have two accounts. You can't explain like that. Even if your teammate does bad thing, cheats, like having multiple accounts in Kaggle is illegal. And if your teammate has it, then the entire team is disqualified. It's not just your teammate. So you'll have to choose your teammates really wisely. Private sharing is not allowed. So even if your teammate, without your knowledge, has done a private sharing with his or her friend, then the entire team is going to get disqualified. So you'll have to vet your teammate out before you join with them. Just finding the right set of people, motivation, and spend 2 hours, 3 hours working every day, then I think you can achieve whatever you dream or whatever you want to do. This is just my piece of advice.
Thank you so much for that, Usha. And in fact, I never knew that the private sharing aspect of it. I never actually knew about that aspect in terms of the penalty involved. So I'm really happy that you were able to let all of us know about that part of it, so we can be aware. It's really really helpful. In the meantime, I have posted the link for a survey in the chat as well. Usha, thank you so much. We can't thank you enough for all of the resources you have provided. I think I can speak on behalf of my team and the participants in saying that this has been a very, very, very fruitful and very enjoyable session for all of us, especially for the ones who would like to be involved in terms of participation. I would just like to remind persons about the other sessions that we have coming up. So today was our overview of the challenge in terms of data science and those aspects that Usha spoke about. We have another session next week with two speakers as well. Another data scientist from Suro Media, Aliana Clark, and then a local data scientist from Trinidad, Mindy Mohammed, and they will be speaking about some other methods in data science in terms of interactive hands-on notebook. And then the next workshop following that on the 18th of February, we will have finished training your ML model, what next? So Miss Sarah Ostermeyer from Arthur, USA, she's a field data scientist. She will also provide you with some information and a notebook regarding that. I'm seeing in the chat that someone, all right, so yes, please post the Google links with all the resources. Yes, so we will post the link again. I know that that Usha, you posted the Google link. I'm going to share that link again for you in the chat, and you can actually have that link to move forward with going forward. Any closing remarks or anybody else? Oh, sorry about that, Somia. I think you have one question. Is your hand raised? This is a new hand. Is this a new hand? I'm not too
Yes.
sure. Okay, great.
Yes,
Go ahead.
I have just, Ms. Usha, this is great that during the competition, how do we learn? But once the competition is over, how do we continue for beginners like me? How do I continue my data science learning journey? Is because I'm a person who would like to be more hands-on, and that has helped me in learning. So any recommendation of how I can continue my learning journey?
Yeah, what I would recommend is currently what is the job which you're doing, like which domain are you, a little bit about your current job, which will give which will give me clarity on giving you the right
currently I'm working as a data analyst within in identity and security domain. So that's where I'm currently there.
Okay. So
And
what I would
using more of
recommend
my data analysis, that's it. That stops there.
Okay. So my recommendations would be, since you're already familiar with data analysis and the world of data science already, you can get started with intermediate level courses. And if you want something very hands-on, Data Camp has got a lot of hands-on oriented focused courses, which are like very small courses. You can take a quick look at the small courses which are more hands-on focused, and then come back to the standard courses which is generally recommended for deep learning and intermediate level data science or mathematics. For data science is deeplearning.ai, and that's a well formatted course. There's another course from University of Washington, again in Coursera. All of these courses which I'm mentioning is from Coursera. They've got a 4 or 5 course specialization course from University of Washington. It has got the right kind of theory and the right kind of hands-on. It's a very hands-on oriented course. Sometimes this deeplearning.ai specialization rubs certain people off. I've had a lot of my students coming back and telling me they did not like it, or that's like too much of mathematics or something didn't go well with them. So but almost all of my students found the University of Washington specialization really good. It's in Coursera. It's a 4 or 5 course specialization. Check that out. It's a well created course. And so get a formal certifications, or if you're already very familiar with all the techniques, get started with building a good project portfolios. Because at the time of the interview, what actually matters is not the number of certifications which you have, how many meaningful projects which you have, which you have in your portfolio matters a lot. If you're switching jobs to a different company, internally also you can switch if there are openings, try for that as well. So projects, find out some real world use cases, find out some open source data set for social goods and things like that, and get started with applying some techniques which you have learned from these courses on those open source data set, and find out all the existing research in that particular domain, and what can you add new to it, publish it in the form of a paper, things like that. Having some research paper publications and having good portfolio of projects can definitely help you make the switch faster. So work on creating a good portfolio of projects, I think. Or you can participate in Kaggle competitions as well. Most of the Kaggle competitions, especially medical segmentations, comes from the research domain, Radiological Society of North America. And there are a lot of research problem competitions as well. So that also you can see. It's not like taking somebody's notebook and putting that in your GitHub. It's about these are ideas which are already there. What new I can contribute to the existing current pool of ideas is what people are looking at. So you need to add some contribution to the existing pool of ideas. That will be the deciding factor in the interviews for you. That will be the factor which will distinguish you from the rest of the group. And one common thing which I notice in a lot of candidates is they put very basic projects like MNIST, Titanic, or very, very basic projects. avoid putting these projects in a portfolio. Always find out some good data sets, open source data sets. Ensure your project stands out from the rest, because there's a lot of competition in data science, at least in some of the countries. There are a lot of people that are doing the masters, and there's heavy competition for job switching and things like that. So if based on the country which you are in, if there's a lot of competition, then you'll have to really work hard in creating some unique projects which will help you stand out from the crowd, and practice the interviews questions really well. And then you're all set for the transition. This is my recommendation. Yeah.
That's super. Thank you very much.
Yeah. Welcome.
Excellent. That was really some very, very great advice, Usha. Thank you for that. Anybody else has one last burning question before we end off our session today? And please remember, if you have any questions for Usha, remember she is available on LinkedIn. You can connect with her there. She's also on Twitter. She provided those links in the file, the link that she sent earlier, the Google Docs link. And you can also feel free to go to our webpage as well, widstt.org, to navigate to find information on her and any of the other events and speakers. So on behalf of the team and for all the participants today, I would like to just tell everyone a huge thank you for being part of our session today. An even bigger thank you to our featured speaker for being part of our session and giving us such great mentorship in terms of the competition and even beyond the competition. And I wish you all good luck in the competition, and even aside from the competition, good luck in your data science journeys in wherever you are in that journey. And we look forward to seeing you in our upcoming sessions. Just remember to fill out the survey link before you leave, and have a great day, night, evening, wherever you are. Usha?
Yeah, thank you so much, Letetia, and thank you so much to the audience, for everyone for coming on a weekend. Meet you all. Best wishes for the competition. Have a great day ahead. Yeah, thank you. I'm signing off now. Yeah, thank you. Bye-bye.
Okay, great. Thank you. Take care to everyone.